Darkness, a hush. Then, like a breath drawn across the cosmos, the faint glow of a smudge in the northern sky. The kind of light you notice only when everything else goes quiet. The universe is crowded with cities of stars, many larger, brighter, and denser than our own Milky Way. Distance dims them into silence, except one, a ghostly lantern we can find with unaided eyes, a neighbor that has revealed as much about the universe as it has about itself. This is the story of Andromeda. If you love cosmic stories like this, tap like and subscribe. Your support keeps these journeys going. It goes by many names. Andromeda, because it lies in the constellation of the princess from old mythology. M31 in Messier's catalog. NGC 224 to those who count galaxies the way mariners count islands. On clear autumn and winter nights in the northern hemisphere, it appears as a pale blur, a fingertips smudge on black glass. For centuries, it was mistaken for a cloud inside our galaxy, a nebula, close and domestic. In 964, the astronomer Al-Sufa recorded that blur as a little cloud. Later, with the invention of the telescope, Simon Marius peered again and wrote it down anew. By 1764, Charles Messier tagged it as the 31st fuzzy object, something to ignore if you were hunting comets. Herschel thought it close, red-tinged at the heart. Parsons drew spirals and grouped it among spiral nebulae. But a few persistent minds, starting with Immanuel Kant, wondered if that cloud was an island universe, a galaxy of its own, far beyond anything then conceivable. The idea sat on the edge of plausibility until a spark in 1917. A nova flared in M31. Haber Curtis scoured old plates and found more. Too many, and all curiously faint. The implication was unsettling. If they looked dim, perhaps they were not weak, but far. In 1920, in a hall filled with anticipation, Harlow Shapley argued that the Milky Way was the universe entire, while Curtis held the line for island universes. The debate ended without a verdict. 4 years later, Edwin Hubble aimed the Hooker telescope, measured the rhythmic blinking of Cepheid stars, and in their pulses found a distance that could not be ignored, well over 1 million light-years. The spiral nebulae were galaxies. The universe was suddenly, terrifyingly vast. What do you think? Were you Team Shapley or Team Curtis? Drop a comment. Proximity made Andromeda our mirror, because it is close in cosmic terms, about 2.5 million light-years. It became the place where we could study a spiral galaxy from the outside, and by reflection, understand our own. Radio astronomers traced its hydrogen. Space observatories painted it in ultraviolet, infrared, and X-ray. Hubble's mosaics stitched together a city of starlight. Within its bounds, we mapped clusters, dust lanes, blue supergiants, neutron stars, and the steady throb of black hole candidates. Here was a galaxy larger than ours, its visible disk stretching roughly 120,000 light-years, its extended outskirts nearly doubling that reach. It is a barred spiral like the Milky Way, but warped by a turbulent past, rings and fractured arms, scars from encounters written into its shape. Beyond the luminous city lies a ghostly atmosphere, a halo of hot, thin plasma that swells more than 1 million light-years from the core, halfway toward us. Suspended there, more than 20 dwarf companions circle like moths around a lantern, survivors of close passes or remnants of meals already eaten. M32 shines as a compact golden ember, only a few thousand light-years wide, fastened by a black hole 1 million suns in mass, likely the stripped heart of a once larger galaxy. M110, dust-veined, trails faint streams that betray old tides. Between our galaxy and Andromeda stretches the Great Quiet. Leaving the Milky Way's plain, the fog of starlight thins. Interstellar space already feels empty, mere thousands of atoms in each cubic meter. But intergalactic space parades that down to a handful. Not nothing, but close. A loneliness where even light seems to tread carefully. Here drift the exiles of collisions, runaway stars and orphaned planets. Worldlets without suns freeze from atmosphere to core, lanterns never lit. Approaching Andromeda, we first meet its halo, then the extended disk, an airy field of scattered, tidal-tossed stars, and at last the bright city itself. Infrared views sketch concentric rings. Hydrogen maps reveal 2 principal arms fractured into segments, each junction a nursery where gravity coaxes gas into fire. NGC 206 stands out, a star-forming region 4,000 light-years across, seeded with hundreds of luminous blue supergiants, stars so swollen the sun would be a spark beside them. Andromeda bristles with globular clusters, more than 460, dense ancient hives of stars. And then the core. Andromeda's heart is a puzzle split in two, P1 and P2, twin peaks of brightness circling a common gravity well. The true center, P2, harbors a supermassive black hole measuring over 100 million solar masses, a titan fattened by the fuel of mergers. Compared to the Milky Way's central black hole, it is a leviathan, a difference born of history. Galaxies grow by encounter. Andromeda has fed well. Not all motion in the universe is flight. Most galaxies recede from us, their light stretched red by the expansion of space, but Andromeda advances. Its light is blue shifted, its approach measured at about 110 kilometers per second. Gravity binds the local group, and over the coming billions of years, what is near will become nearer. Slowly at first, Andromeda will swell in our night sky, a breath becoming a cloud becoming a continent. In 2 billion years, it will rival the moon in scope. In 4, our spirals will intersect, tidal arms raked into lace, gas shocked into a last fever of starbirth. Curious how that merger might look from Earth? Subscribe so you don't miss our visual breakdown next. Star meets star only in the rarest accidents. Space is too spacious for head-on crashes, yet gravity's hands are large. Planetary orbits wrench and tilt. The sun and its retinue may be flung outward into a dimmer suburb, or inward toward the storm at the new core, or by some wild throw, cast into the darkness between galaxies. At the center, 2 supermassive black holes will find each other. They will circle, scatter stars to bleed away momentum, then, when close enough, shed energy as gravitational waves, ripples in space-time that ring the cosmos. At last they will merge, and a single greater anchor will form. The remnant galaxy, an immense elliptical, smoothed of spiral structure, will settle. Tens of quadrillions of years from now, the last luminous stars will cool toward blackness. White dwarfs will fade. The night will thicken. The story of Andromeda and the Milky Way, once 2 spirals flirting across a gulf, will end in a single silent structure under an ever-emptier sky. But we are not there. We were born mid-story, long after the violent opening, long before the final hush. Look up on a cold, clear night. Find that pale oval near Cassiopeia's W and Perseus' blade. You are seeing 2 million years across space, and in a way, across time, light that left when early humans were new to the world, arriving now to meet your eyes. Hold it for a moment. Let the scale settle. The smudge is a galaxy. The galaxy is a future. And the future, unbelievably, includes us. If this left you with wonder, like the video, subscribe for more sky stories, and comment with the next object you want us to explore.